So in this episode, we look at some of the recent improvements made by Databricks to structured streaming. If you would like to know more about streaming frameworks and how we got here where we are today, then do have a look to my previous talk, wherein I shared my experience and evolution of streaming frameworks over the last few years. Let's get started with today's topic, wherein we cover the recent improvements in the structured streaming. While I was going through some of the references by Databricks, in the last 1 year, I found that the Databricks has been focusing on further lowering the latency and improving the stateful stream processing. Stateful stream processing, as I mentioned earlier in my previous episode, means that a state is shared between events and therefore past events can influence the way current events are processed. This state can actually be queried from outside the stream processing system as well. Now, in order to lower the latency, Databricks focus on checkpointing. Until now, structured streaming used to support synchronous checkpointing, where the state updates are written to a cloud storage checkpoint location before the next microbatch begins. The advantage was that in case of failure, the job can easily restart by using the information of the last successfully completed microbatch. However, there is considerable amount of delay involved between capture of state of the current batch and start of processing for the next batch. In order to overcome this, Databricks introduced asynchronous checkpointing, in which the microbatch does not have to wait for state updates to be written, therefore improving the overall end-to-end latency of the execution by 25% at least. It's available in Databricks runtime 10.3 and above. That's another thing, that not all streaming workloads can reap the benefit of asynchronous checkpointing. For more details, I would encourage to look at the Databricks reference documents. Another improvement that has been made towards improved stateful stream processing is using arbitrary or custom stateful processing. Now, to understand this concept, think about a scenario which requires you to emit an alert based on a group or type of events only in case if they exceed a threshold over time. Now, this scenario may require you to provide an initial state of events, thereby avoiding the need to reprocess all the streaming data which has come before. With the recent arbitrary and stateful operator improvements, you can provide an initial state to mark the aggregated value for the history and go ahead with incremental processing on stream data. Databricks also added native support for session windows. It is known that structured streaming introduced the ability to do processing over event time-based windows, majorly in a tumbling and sliding window patterns. Unfortunately, both these patterns are fixed in length. With Spark 3.2, session windows have been introduced to allow dynamic window lengths, which are fairly easy to configure and use. The second area that Databricks focused on improving observability of Databricks and Spark structured streaming workloads. This revolved around RocksDB integration. Now, why RocksDB? Take a scenario where the stateful stream processing is required and also there is a need to maintain millions of keys in the state. This state is usually maintained in the JVM memory of the executors. Now, due to large number of state objects, there is a high chance that you may face issues related to large JVM, garbage collection pauses, causing high variations in microbatch processing times. To overcome this, RocksDB-based state management solution was introduced. Rather than keeping the state in the JVM memory, RocksDB, the state is maintained in the native memory of the local SSD. Third one, coming to observability. In Databricks runtime 8.3, real-time metrics was added to help understand the performance of the RockDB state store and debug performance of state operations. Given the engineers more control the state changes and identify target workloads for asynchronous checkpointing. Now, in this episode, I have talked about two areas. Number one, lower latency and improving stateful stream processing. Number two, improving observability of streaming workloads. If you are working with streaming workloads or plan to have work with them in the near future, I hope these updates will help you in that journey. Feel free to reach out to me through your comments. I'm eager to learn from your experience. My intent is to simplify the concepts and bring them to you. If this helped you to build some understanding, then I think it's a good idea to like the video, subscribe to the channel, and share it on LinkedIn or where your peer group is. Until we meet next time, keep the beat flowing.